Welcome to Physics World Online College, where we simplify the concept of physics and make it very simple for you to understand and also pass your exams. In our class of today, we shall consider distance. This is for SS1, ST1 class. So under this topic, we will look at the definition of distance and its unit. We'll look at how to calculate the distance between 2 points, both in 2-dimensional and 3-dimensional Cartesian coordinate system, and we'll look at distance and direction. Please remember to subscribe if you have not done so, and share this class video at the end of the class. You can share it in your social media handles so that your friends will be aware of what is happening on this channel. We'll continue with our class for today. Distance is defined as a measure of the separation between 2 points. If you have 2 points, point A and another point B, we want to know how far is point B from A. We will know by measuring the what? The distance between what? A, B. So let's define distance. Distance is defined as a measure of the separation between 2 points. The SI unit of distance is meter. We'll use small letter m to represent it. Distance is a scalar quantity. What does that mean? That distance has only numeric value, only magnitude, but no direction. So I said it is a scalar quantity. Now, how do we obtain the distance between 2 points in 2-dimensional Cartesian system? To calculate the distance between 2 points in 2-dimensional Cartesian coordinate system, in the 2 Cartesian coordinate system, we are dealing with the x, y coordinate system. We use the formula. So if we have point A and is given as x1, y1, is separated from another point B, and B is given as what? S2, y2. To find the distance between the 2 points A and B, which we will call line AB, we will use the formula that distance of line AB will be equal to square root of S2 minus S1 all square plus Y2 minus Y1 all square. So this formula we will use to find the distance between the 2 points A and B. S1 is the S coordinate value of point A, also called the abscissa. Y1 is the Y coordinate value of point A, also called the ordinate. S2 is the S coordinate value of point B. We can also call it the value of B in the S axis or S direction. Y2 is the value of B in the what? Y direction. Good. So if point S1 and Y1 are known, point S2 and Y2 are known, we can calculate the distance between what? The 2 points A, B by using this formula: S2 minus S1 all squared plus Y2 minus Y1 all squared. We'll take the square root of the addition. Then we will get the distance between the 2 points A, B. Likewise, in three-dimensional Cartesian coordinate system, we will use the formula to calculate the distance between 2 points in the three-dimensional Cartesian coordinate system. The three-dimensional coordinate Cartesian system talks about the X, the Y, and the Z coordinate system. We use the formula that we say, let me call this point P, is given by X1, Y1, Z1, separated from another point Q, given by S2, Y2, Z2. To obtain the distance between points P and Q, let's call it the distance of line PQ. Observe the way I represent this distance. Here I say distance line AB. Now I'm saying distance line PQ. So you can represent it this way or you can represent it this way. You are right. Good. The distance PQ will be given by the square root of, I will do S2 minus S1 all squared plus Y2 minus Y1 all squared plus Z2 minus Z1 all squared. So you will see it's just an extension of this two-dimensional Cartesian coordinate system. Only now that we're including the directions of Z. So we are going to use these two formula to calculate the distance between 2 points. We will apply it in example 1, 2, and 3. Then you will do this classwork and submit to me for assessment. Let's take a solution to the example 1. Solution to example 1. So we're given the 2 points. Say calculate the distance between the points A, 2, 3, and B, minus 5, 1 on a plane. So we're given point A as 2, 3. What does that mean? The first value that is listed is the S value or the S coordinate value, or the value of A in the S direction. So this means that X1 is 2, and then the second value listed is the what? Y value, that is the value of A in the Y direction, in the vertical direction. So it means that y1 is equal to 3. Then our point B is given as minus 5, 1. What does that mean? B is the second point, which means that S2 is minus 5 and y2 is equal to 1. So since what we have is the S and Y value, since what we have is the S and Y coordinate value, since what we have is the value of A in the S direction and in the Y direction, it means we are dealing with the what? With the two-dimensional Cartesian coordinate system. So for us to get the distance between A and B, we are going to now use the formula that the distance of line AB is equal to square root of S2 minus S1 all square plus Y2 minus Y1 all square. So we are going to do the substitution now. That will give us that the distance of line AB is equals to square root of, in place of S2 now, I will put minus 5, minus, in place of S1, I will put 2. I'll close it, put it in bracket and square, plus my Y2 is 1, minus my Y1 is 3. I close it in bracket and square. Please, while making this substitution, you must be careful of the negative sign. You must be very careful in order not to misuse that negative sign, which will lead to a very wrong answer. So you must be very, very observant as you work the values, including the use of the negative sign. So what do we have next? We say the distance of line AB is equals to square root of, this is minus 5 minus 2. That will give us minus 7. Please take note, the minus is inside the bracket, raised to power 2, which means the square will affect the minus sign as well as the 7. So I advise as a student, please do not write it this way. If you write it as minus 7 square, oftentimes students will now square only the word 7 and ignore the minus sign, and that will introduce error in the work. So please put it in bracket, and that means that both the minus sign and the 7 is affected by the square. Plus, we have 1 minus 3. That will give us minus 2. Once again, you have to put it in the bracket, meaning it is affected by the square sign. So once we take the square of minus 7, that gives us 49. If we take the square of minus 2, that gives us what? 4. So we can add it. That will give me that the distance of line AB is equals to the square root of 53. Now, you will observe something. I've warned you about ensuring that if there's a negative sign coming out after subtracting, that it is put inside the bracket, and the square will affect both the minus sign and the what? The value. Watch out for that. Then we discover that in the question, no unit was mentioned. I can decide to leave this as a square root of 53. If that's where they want us to express it, we end the answer there. However, you have access with calculator. You can press the square root of 53 and you will get a value of 7.28. 7.28. Now, because no unit was mentioned in the what? In the question, what we will put? You will put unit here after solving the question. Now, this is different from the example 2, where we are told that we should, where we are told that if you are told to put the distance in meter, Okay, put the distance in meter, then you must express your unit in terms of meter. So here in this example 1, nothing was said, so we put units after solving for the what? The distance. Good and fine. So let's look at the solution to example 2. Solution to example 2. Now, there's a reason I'm doing example 2. It's just to show us how to handle the minus sign. To be very careful how you handle the minus sign, because like I said, if not handled properly, it will introduce error into your work and you will not get the correct answer. So let's look at example 2. What are we given there? We are told to find the distance in meters. So this one you are told what you need to express it. So you will not use unit at the end of the answer. Rather, you will use meter. So I have said in this first example, I use unit here after the answer because I was not told in what unit to express the distance. So you will use units after the answer. Good. So they say calculate the distance in meters between the points P and Q. So we are given point P as -1, 5. What does that mean? This means that our S1 value is -1 and our Y1 value is what? 5. And then they say Q is given as -4, -10. So we have -4, -10. What does it mean? It means that our S2 is what? -4 and our Y2 is -10. Now, I'm going to quote the formula for distance between 2 points in the two-dimensional Cartesian coordinate system. So I'm saying therefore that the distance of a line PQ will be obtained by using the formula S2 minus S1 all square plus Y2 minus Y1 all square. So if I substitute, that will give me distance of line PQ as square root of S2 is -4 minus, now -1 for S1. Remember, the formula has negative sign. S1 also have what? Negative sign. What will you do? You will open a bracket to put that -1. So that tells you that, hey, be watchful. This S2 has -4. It has a minus sign. Then there is a minus sign from the equation you have quoted. And then S1 has its own minus sign. So you have to wash it very well. Otherwise, there will be error introduced in the work. So I have -4 minus, I open bracket, -1. I close the bracket, then another bracket square. Then plus Y2 is -10 minus Y1 is 5. So you see, I didn't put another bracket there. So this minus comes from the formula. Good. This minus comes from the number Y2. So you have to be very careful. This is the reason why I'm solving the second question. So you observe where you have multiple minus signs and know how to address them. So we have the distance PQ is equals to square root of, how do I treat this? This is -4. This minus, we multiply this minus and change it to plus or square. Then plus -10 minus 5. That will give you -15 all square. Please, why this one is minus times minus? Because there's a bracket there. Bracket sign means times. So this is minus times minus. This one is not minus times minus. This one is, you are adding two negative signs. -10 minus 5, giving you what? -15. You must know the difference, though that is more of mathematics than physics. So this is minus bracket minus, that is minus times minus, which changing it to plus. This one is -10 minus 5, that is adding two negative values, giving you what? -15. So they are not saying the same thing. Good. So we have that the distance PQ is equals to square root of minus 4 plus 1. That gives you what? Minus 3 square plus minus 15 square will give you 225. We have the distance PQ, square root of minus 3 square is 9 plus 225. When we add it, will give us the square root of, that will be, if you put 9, put 5, that's 3, 4. So 2, 3, 4. Like I said, if I have no access to calculator, I can stop here. If it is OBJ question, the answer may stop here. You stop here. But if you have access to calculator, you take the square root of 235. The square root of that will give me 15.29. So I have the distance PQ as 15.29 meter. Why am I putting meter? I was told to calculate the distance in what? In meters. So I'm putting meters here. Unlike the first one, I put unit because nothing was what? Specified. I believe you get that explanation very well. So let's look at example 3 that deals with 3-dimensional Cartesian system, where we have x, y, and z value. So we are going to use that extended formula to obtain the distance. Let's look at it. We say solution to example 3. Solution to example 3. So we are given to calculate the distance between the points n minus 2, 4, 8 and m minus 5, 4, minus 3. So we are given the point n as minus 2, 4, and 8. What does that mean? The first value quoted is the s value. So we call it S1 is minus 2. The next value is a what? Y value. Means Y1 is 4. And the next value is the what? Z value. Meaning Z1 is what? Is 8. Then we have M given to us as minus 5, 4, minus 3. What does that mean? Once again, the first value is the S coordinate, the S value, the value in the S axis, also called the what? Abscissa. So it means S2, that is the second point, is what? Minus 5. The second value is a Y value, the value in the what? Vertical direction, the Y coordinate, also called the ordinate. So Y2 is given as what? 4. And then the last value is a what? Is the Z value. So Z2 is given as what? Minus 3. So to get the distance between the 2 points MN, so we say distance NM, that's line MN. Let me use this symbol now. So you can choose to use any one. You are correct. So we give me square root of x2 minus x1 all squared plus y2 minus y1 all squared plus z2 minus z1 all squared, because this is the what? 3-dimensional coordinate system. Please, the square root covers all of them. Don't draw it half in order not to run into problems. So we substitute our value, take square root. In place of S2, I will put minus 5. Once again, be very mindful of the negative sign. Our S2 has minus sign. The minus sign that comes from the equation, at the center. Then S1 also have minus sign, so I will open a bracket and put it as -2. I close the bracket and square. So I will have plus my y2 is 4, minus sign from the equation, y1 is 4, and square. Then we have z2 is -3, minus from the equation, our z1 is 8, and square. So once again, you will do that mathematics have said. This is -5. This minus will times this minus, changing it to +2 all square. Then this is 4 minus 4, that is 0. So we are having 0 what? Square. Plus, this is -3 minus 8. It means adding two negative values. Like I said, is different from this one. Please take note of that point. When you do -3 minus 8, you are adding two negative values. That is not the same thing as multiplying two negative values. Please take note of that and do not make a mistake. So this will give me what? -11 all square. So I will now have that my distance mn is equal to square root of -5 plus 2. That will give me -3 all square. 0 square is 0, plus -11 square. That will give me 121. Then I have the distance mn equals square root of -3 square is 9, plus 0, plus 121. So 9 plus 121 will give us what? 130. Square root of 130. Once again, I can stop there if I'm without calculator. Now, in this question, we're not told express the distance in meter. So which unit am I going to put there? I will put unit if I'm stopping here. But if I have access to calculator like you take the square root of 130. You take the square root of 130, you are going to get 11.40. 11.40, and I will put what? Unit. I believe by now you understand the reason and when to use what? Unit, and when to use what? Meter. So if the question states it, find the distance in this, you have to indicate that unit. If not, you put a unit. Good and fine. So we talk about distance and direction. So I believe you now know how to calculate distance between 2 points, and you know the SI unit of distance, meter. When you are told to express it in meter, you do. If they say express it in cm, you express it in cm. If nothing is mentioned, put unit after doing the calculation. Please, we have distance and displacement to discuss. Let me just throw some highlight there. Now, distance, like I said, is a measure of separation between 2 points. It tells you how far a point is from another. However, it does not tell you where the object is, and does not tell you in what direction the object is. So that becomes a problem when you are not able to specify the direction of an object. And in physics and in motion as in particular, it is important to specify the direction of what? Of objects. So distance and its direction, when specified, we call it displacement. So I will consider that in the next class. So we'll be talking about what? Displacement, which is distance traveled in a specified direction. This is an assignment for you to do. You do it and submit to me. I will remark on it and tell you what to do. I'll see you in the next class. Bye for now.